process of sending data wirelessly. It can be compared to radio communication, and microwaves work on the electromagnetic spectrum with its working frequency between 300 MHz to 300 GHz. It was first developed during World War II in relation to military radar research. This type of communication is very essential as it transmits data in long distance without any physical wires through installation of transmitters and receivers on high towers for a clearer line of sight to the next tower, and also high tower reduce the impact of the Earth's curvature.
Hi, I'm Angelo Protacio.
And I'm Kenneth de Mesa, and we're going to show you a step-by-step tutorial in making a microwave link design project.
And now, we're here to talk about the advantages of microwave link.
It's less affected by natural calamities.
It's less prone to accidental damage. Links across mountains and rivers are more economically feasible.
Single point installation and maintenance. It also has single point security. In designing a microwave link, you have to go through a methodological and systematic process. This process includes loss and attenuation calculation, fading and fade margin calculation, frequency planning and interference calculation, quality and availability calculation. The sets of processes may undergo through set of recomputation to further achieve the desired quality and reliability set by the instrument.
For the client part, you will need to start with determining a client that will give you a location where you'll put the direct link of your design. A client can be a company that specializes in telecommunication, BPO company, or any company that has a concern in data transfer.
The first step is to get a client to set an interview from an engineer inside the company. Note, you should not forget to tell them that this is for educational purposes only. For the interview questions, first, location to be linked. They might give you a two location or set of location to be linked. The location is given will determine if the link will need a diversion. Second, desired frequency. Some company will give you the desired frequency, but some will not. So you need to know how to choose a frequency.
Let's discuss frequency planning. Frequency planning is done to assign the frequencies going to be used for the radio links to have it as a few as possible. But at the same time, it has the quality and availability that can be affected minimum by interference.
There are many factors to consider in assigning the radio frequencies. First is the frequency band that can match the link. You have to consider the path length, site location, terrain, and atmospheric effects. As a general rule, the lower the frequency, the farther the microwave link. An approximated relation for the range of frequency and distance is shown in this table.
Also, remember to check the area to match frequency going to be used that's suitable for the bodies of water near the path.
Second, You have to take note of the possible interference among radio frequency channels in the path. You should check for other radio paths in the area and also possible interference to and from satellite communication systems.
Third, the frequency band that will effectively carry the data correct. Correct selection of frequency band allows the required transmission capacity while efficiently utilizing the available radio frequency spectrum.
The assignment of a radio frequency is an authorization given by an administration for a radio station to use a radio frequency under specified conditions. It is created in accordance with the Series F recommendations given by the ITU-R.
In frequency channel arrangement, first, the available frequency band is subdivided into two halves, a lower and an upper duplex half.
Second, the duplex spacing is always sufficiently larger so that the radio equipment can operate interference-free under duplex operation.
Third, third, third. The width of each channel depends on the capacity of the radio limit and the type of the modulation used.
The most important goal here in the frequency planning is to allocate available channels to different links in the network without sacrificing quality and availability because of radio interference.
Now that you have completed the objectives in the client part, don't forget to be polite in this part of the project.
A topographic map is a type of map characterized by large-scale detail, a quantitative representation of relief, usually using contour lines, but historically using a variety of methods. The traditional definition requires a topographic map to show both natural and man-made features. The maps in 711 series at scale of 1 is to 50,000 were originally published by U.S. Army surveys and were compiled from the aerial photographs taken from 1947 to 1953. The Series 711 maps were replaced by the maps of 701 series. The 701 series was produced using aerial photographs taken in 1979 and only covers the Luzon Island. Replaces both S711 and S701 maps. It covers the whole Philippines in 672 sheets. The NTMS maps are in by 15 interval and elevation are in 20 meters contour line intervals. As you can see, this is a close view of what the path looks like. I drew a pen on the topo map to make the link visible. As we take a closer look, you will notice a separation of lines between the path. This is used to path profile the link in every 1 kilometer of the path. You will then observe in every kilometer of the path if there are any point that will reflect the signal. You will see this on the legend part of the map. One can reflect the signals or bodies of water like lakes, ocean, and also rice paddy can cause reflection, so better check the profile of the path carefully.
Now, let's discuss the formulas that are necessary in designing a microwave link. Also, the techniques on how to lessen the work in computation to conserve time in working on this design. Also, as we go through the formulas, we are going to discuss important information on the factors that affect the result of the computation in the design, as well as the process that will be encountered during the process of computation. So I need you to get a pen, I need to grab a paper, and then let's go grab some computations.
So remember to take note of the following formulas for this computation. Now, for the azimuth, the formulas are
An angular measurement in a spherical coordinate system. The vector from an observer to a point of interest is projected perpendicularly to a reference plane. The angle between the projected vector and the reference vector on the reference plane is the azimuth.
in path profiling, you need to get the distance calculation of the link.
Also, the actual measurements using the topographical map. Now, here are some ways to calculate the Earth curvature.
A conception or representation of the shape of the Earth as a planet on the whole. In antiquity, it was already recognized that the figure of the Earth has the shape of a sphere.
Now, this is the formula for the line of sight.
And also for the reflection point.
The line of sight is the ability to see the one end of the link to another. It is also the electromagnetic waves traveling in a straight line.
So now let's go to the path calculation. The first one is the free space loss.
In telecommunication, free space path loss is the loss in signal strength of an electromagnetic wave that will result from a line of sight path through free space with no obstacles nearby to cause reflection or diffraction.
And now for the atmospheric losses of oxygen absorption loss and water vapor absorption loss. Here are the formulas. Take down.
Total attenuation through the atmosphere at any frequency through unobstructed atmosphere is the sum of free space path loss, attenuation caused by oxygen absorption. Total attenuation through the atmosphere at any frequency through unobstructed atmosphere is the sum of free space path loss, attenuation caused by water vapor absorption.
We also have the transmission line loss.
Transmitting electricity at high voltage reduces the fraction of energy loss to resistance, which varies depending on the specific conductors, the current flowing, and the length of the transmission line.
And now, the total system loss.
Now here's the system gain.
Two thousand years later.
And now for the total system gain.
The total system gain is the sum of all the system gains of different networks in which it describes the amount of power obtained or dissipated.
Now let's go to the received signal level.
The signal level of the receiver input terminal. Take note, the signal bandwidth and the established reference level must be specified, and the RSL is usually expressed in decibel with respect to 1 milliwatt.
The effective isotropic rejected power, or EIRP. These are the formulas.
Uh, 6.5 hours later.
Mabilis na. And now we go to the part of the fade margin calculations for the path. Here are the formulas. First, the objective fade margin.
Few inches later.
Second is thermal fade margin.
A few moments later.
Third one is flat fade margins.
Eventually.
And the last one is the composite fade margin. The last part of this calculations will be under reliability calculation. First one is non-diversity, and you also need to solve the unavailability and reliability.
And now for the KQ reliability. This is the formula.
Tomorrow for sure.
We also have here the KQ with terrain roughness reliability.
And also we have what they call the Vigas-Barnett formula.
A method not administratively sanctioned multipath fading model as such, but is based on the published work of two microwave system researchers at AT&T Bell Labs.
Let's go to improvement factor of frequency diversity.
And now we have the formula for the rain reliability.
We also have the rain attenuation. CCIR RAC 530 was used to compute for rain attenuation, since the method is only applicable for path lengths that exceed the applicability of crane rain method, which is 22.5 kilometers. Here's the formula.
Based at the CCIR climatic table, the rainfall rate for the Philippines, especially in Luzon Island, is area N or 180 mm per hour at an unavailability of 0.001%. Now here's the computation for the effective rain path length.
Lastly, we have the unit rate attenuation.
Meanwhile, one eternity later.
Now, I'm here to present a video that will help you navigate the Google Earth in designing for a microwave link. First of all, let's have a quick overview on Google Earth. Google Earth is a virtual globe, map, and geographical information program that was originally called Earth Viewer 3D, created by Keyhole Incorporated, an information system onto a 3D globe. Now, let's start. As you can see, this is the interface of the Google Earth. You can see everything around the globe. First, of course, you have to look and zoom in for the desired location of your design. As you can see, you have a nice overview of your location. Now, to mark your location, click on this yellow tab. It is called the Add Place Mark tab. As you can see, a window will pop out. It will show the latitude and longitude of the location. Then place a name for the location. Let me type direct link. Also, let me put another destination of the first site chosen. As you can see, on your left side of the screen, on the Places tab, you can see the site you have marked. You can also on and off it like this. Then, click on this icon. This is the ruler command. A window will pop out. As you can see, you can choose the unit of your link. Then click on your first location. You will notice as you drag your mouse, the length increases. This indicates the distance. It will help you know the exact distance of your direct link. In each hop, this will be also verify if you have reached a standard minimum of 10 km per hop. Now, click on the next location. It will show the total length of the first link. Then click on Save. Choose a desired name for this link. Let me type in direct link. Notice an icon will appear right here. It will indicate the link. Now you have the link. Right click on the link, then click Show Elevation Profile. As you can see, the elevation of the path will shown on the lower part of the screen. You may now check on the elevation per 1 km of your link with this command. Also, with Google Earth, you can merely predict the obstruction on the link of your design. By using the street view, you can know if there are any obstruction or building around the site. But of course, visiting the site in person is more accurate.
So here is a website where you can choose some of the materials that you can use for the microwave link. So under products, you can go to wireless, and then you can go under antenna systems and point-to-point microwave. Once it loads, you'll see all available items and materials for point-to-point microwave. And under antennas, you can see that you have different ways to classify an antenna, as well as to choose for a specific antenna with respect to the frequency. You can also choose the diameter of the antenna that you're going to use. There's also a list here of sample antennas that you can use, and it also has a description noted. One example here is the HP10-105. You can also see all the specifications of this antenna, and you can match it with the desired specification
for your microwave design. You can click here, download the product specification or the documentation, and once you found the right antenna, you can now include it in your microwave design.
Now, I'm here to have a simple discussion in looking on a specification sheet or spec sheet for this microwave design project. A spec sheet is a document that summarizes the performance and other technical characteristics of a product, machine, component, material, a subsystem, or software in sufficient details to be used by design engineer to integrate the component into a system. The spec sheet is an introductory page of describing the rest of the document. Now, as you can see, this is spec sheet coming from CommScope, one of the leading distributor of advanced wireless equipment, broadband equipment, and enterprise cabling solution. The product is a parabolic shielded antenna. To be specific, it is the HSX 12-71-D3M, 3.7 meters in diameter antenna. The necessary information that you need to inspect in the spec sheet when designing a microwave link. First, look at the antenna type. For this one, it is an HSX high performance super high XPD parabolic shielded antenna, dual polarized. Typical types of antenna used in radio relay link installation are parabolic antennas, dielectric lens, and horn reflector antennas, which have a diameter of up to 4 meters. Highly directive antennas permit an economical use of the available frequency spectrum, despite long transmission distance. You will then inspect the operating frequency band of the product, as it will be very important in choosing the product that will fit in your design based on the frequency plan. For this product, the operating frequency band is 7.125 up to 7.750 GHz. After the frequency, another important thing is the gain of the antenna. Antennas used must be highly directional with high gain. These antennas are installed in elevated location, such as large radio towers, in order to be able to transmit across long distances. Also, another important specification is the loss of the antenna. For this one, the return loss is 30.7 dB. The specification sheet may sometimes confusing, but as long as you stick with the requirement of your design, you'll be on track. These are the basic things you need to inspect in looking on a spec sheet. Remember, a good design comes with a good set of equipments.
So you should use higher frequency bands for shorter hops and lower frequency for longer hops.
Avoid lower frequency bands in urban areas.
And in areas with heavy precipitation, if possible, use frequency band below 10 GHz.
Leave enough space capacity for future expansion of the system. Space diversity is a very expensive way of improving the performance of the microwave link, and it should be used carefully as a
Make
last
sure everyone on the project is using the same maps, data, and coordinate system. Perform a good path profiling on the direct map and niche for the hub. In areas with lots of rain, use the lowest frequency band allowed for the project.
microwave hubs over or in the vicinity of the large water surface and the flat land areas can cause severe multipath fading.
Reflection may be avoided by selecting sites that are shielded from the reflected rays.
So once again, in creating a microwave link design, you need to invest time and effort.
And also don't forget to do teamwork. And again, my name is Kenneth,
And I'm Angelo Miguel.
and that's how you do a microwave link design project.
This is yellow. You can see this is yellow. And this is Angelo too.
I'm gonna pick up the pieces and build a Lego house. If things go wrong, we can knock it down. My 3 words have 2 meanings, but there's one thing on my mind. It's all for you. And it's dark in a cold December, but I got you to keep me warm. If you're broken, I will mend you, and I keep you sheltered from the storm that's raging on. Now I'm out of touch, I'm out of luck. I'll pick you up when you're getting down. And out of all these things I've done, I think I love you better now. I'm out of sight, I'm out of mind. I'll do it all for you in time. And out of all these